25. A cricket randomly hops between 4 leaves, on each turn hopping to one of the other 3 leaves with equal probability. After 4 hops, what is the probability that the cricket has returned to the leaf where it started? So, probability question. Again, let's have a quick review. Prob equal to number of cases at work, which means the cricket returns to the original position, divided by number of cases possible. So let's see, you start from A, and let's see the other 3 are B, C, D. At every step, the cricket has 3 choices, equal probability. So either A, B, A, D, A, C, and same thing. If the cricket is at B, equal chance to go to the other 3 positions. So if I look at the denominator, it's going to be 3 power 4. 81 possibilities, or 81 possible routes. That's straightforward. Now let's figure out how many ways can you return to your original position. The challenge for this question as an AMC 8 question 25 is there are a lot of ways, right? Even starting from A, you can choose to go to B first, or C, or D. But then you might start to notice something. Given that the cricket can go to any of the other positions, there is some symmetry for this question, which is to say, if I start from A to B, there's not really much difference from I start from A to C. The ways for you to come back to A is going to be the same. So that simplifies things a little bit. I'm going to say I start from checking the cases. Let's start from A, jump to B. And then I just need to remember to multiply my answer by 3 in the end. Because this question is symmetric. So A to B, then what's going to work is going to be the same amount of ways for A to C and A to D. So that simplifies your counting a little bit. And let's continue on. If you go from A to B, then again, you have a lot of choices. And those kind of counting questions, the most important thing and also the most challenging thing is to count it in a way that you do not miss anything. How can we do that? One way to do so is to always try to make the letter small. I'll write it down. Try to make the letter small. It's only a way to avoid duplication or missing. How do you make it work? Well, I'm at B now. I have choices to go to A, to go to C, to go to D. I choose to go to A if possible. If I can't go to A, I choose to go to B if possible, or I go to C, or I go to D, unless this is a duplicated channel or duplicated route. So A, B, well, no round has been produced yet, so I'll go back to A. And then again, always try to keep the letter small. So A, B, A, then B, then A. This is sort of the route with the smallest letter possible. And now let's see, if you go from A to B, this time I can still go A because that's not totally duplication yet. But now I can't go from A to B anymore because A is going to be the same route. So this time I will need to go to C and then come back to A. And you can probably tell you need to make sure the last but one point is not A. Because if that's the case, you can't go back to A. Same thing, I can go from A to B to A to D, then to A. Now, ABA is used up. because if you go A, B, A, then anything else you produce is going to be a duplication. So now we can go A, B. Again, I'm trying to keep my letters small because that will make sure I don't miss anything. So I can go A, B, C. You can't go back to A because if your last but one step is A, the final position is not A. Well, then I choose a small letter B. Same thing. A, B, C, D, A. A, B, C now is used up. So A, B, D, B, A. Or A, B, D, C. That's everything I have if I start from A to B, and I have 7 ways. Go back to A. Again, I know if I go from A to C, everything is symmetric. So I just need to time it by 3. So I get 21 ways. And in that sense, my probability is 21 over 3 power 4, which is 7 over 27. So the answer is